The next new topic that I want to look at is called integration by parts. And before I even get started, I want to complain about something. Derivatives like dy dx are not fractions. They are limits of fractions, but they're not fractions themselves. For certain purposes, though, we can get away with pretending that they are fractions, although we really shouldn't even be writing stuff like this. In particular, if you look at dy dx equals dy du times du dx, it looks very much like we're canceling out the du's. For some purposes, like the one we're at now, that will work. For others, it won't work at all. It might be worthwhile to write out why what we're about to do works the way that it does. If you take the chain rule that we just looked at, dy dx equals dy du times du dx, and turn that around backwards, that means that the right-hand side, dy du times du dx, is an antiderivative for y. So the integral of dy du du dx with respect to x, that's the dx here, is y plus a constant. If I pretend that these things are fractions, which they're not, the dx's will cancel out. And once I've canceled the dx's out, I can cancel the du's out and get the integral of 1 with respect to y, which is y plus c. No harm is done in this particular application by pretending that dy dx is a fraction, even though it isn't. The strategy fails completely when you do second derivatives, though. We're now going to resort to trickery. Suppose that u and v are functions of x, and I want to multiply u and v together, then take the derivative. We know how to do that because of the product rule. If I then integrate both sides of that formula with respect to x, I get the integral of the derivative of u times v with respect to x, which is u times v, because we're looking for a function whose derivative is the derivative of u times v, and well, u times v, I must integrate the integral of u times dv dx with respect to x, and we're going to pretend that the derivatives are fractions. So cancel the dx's out, and all that's left is integral of u with respect to v. Then do the same here, and you'll have the integral of v with respect to u. If you subtract this last quantity from both sides, you find out that the integral of u with respect to v is u times v minus the integral of v with respect to u. This is called the integration by parts formula, and it seems to be completely crazy when you look at it. As an example, I want to find an antiderivative of x times natural log x. And if I haven't mentioned it before, you cannot do the antiderivatives separately and multiply them together. That doesn't work. Thinking of this as in the previous pages, I'm going to think of having three factors here: x, natural log of x, and dx. I want to think about this as integral of u dv. There is a number of different ways I could think of grouping these things together. I'm going to think of u as being natural log of x, which means the dv has to be all the other factors, in this case, x dx. Derivative of u with respect to x is 1 over x. Du, pretending that the derivatives are fractions again, is 1 over x times dx. If dv is x dx, then dv dx is x. That means that v must be an antiderivative of x, and one such antiderivative is 1/2 x squared. Then I want to write down u times v minus integral of v du. U, u is natural log of x times v, which is 1/2 x squared, minus integral of v, which is 1/2 x squared, du, which is 1 over x times dx. Makes a person uneasy even saying that. After doing all the now simpler integrations, we get for an answer 1/2 x squared natural log x minus 1/4 x squared plus a constant. This seems crazy, so I'm going to check it. I'm going to make sure that my answer is correct. I'm going to take the derivative of my answer and see if it's what it's supposed to be. So I need the derivative of 1/2 x squared natural log x minus 1/4 x squared plus a constant. For the first piece, I have to use the product rule on that. So I'm going to have 1/2 times derivative of x squared, which is 2x, times the other factor, natural log x, plus 1/2 x squared times the derivative of natural log x, which is 1 over x, minus the derivative of 1/4 x squared is 1/4 times 2x, which is 1/2 x, and the derivative of a constant is 0. Simplify, these 2's cancel out, so that turns into x natural log x. Here, a factor of x cancels out, resulting in 1/2 x, and I am subtracting away 1/2 x. So the derivative of this alleged answer is actually x times natural log of x, and this crazy integration by parts idea actually worked. Because there were 3 factors involved, I could have made different choices. So I want to look at what would have happened if I'd made a bad choice. What if I decide to make the u equal to x, and dv, being all the other factors, has to be natural log x dx? The derivative of u with respect to x is 1, so du is 1 times dx. dv, being natural log x dx, means that the derivative of v with respect to x is natural log x, so that v will be an antiderivative of natural log x with respect to x. Unfortunately, we don't know that. We don't know a function whose derivative is natural log of x. We know that the derivative of natural log x is 1 over x, but that's not what we have to figure out here. The way out of that problem, ironically, is going to be integration by parts. If I look at the integral of natural log x dx, there's only 2 factors. So if this integration by parts idea is going to work out for me, one of the factors has to be natural log of x, and the other one has to be dx. I can't let just natural log x dx be dv because I don't know how to calculate that. I'm going to let u equal natural log of x. Derivative of u with respect to x is 1 over x. du is 1 over x dx. On the other hand, if dv is dx, that means the derivative of v with respect to x is 1. V is an antiderivative of 1, and the simplest thing I can write down is x. So I'm going to write down the integration by parts formula. U times V, that would be x times natural log x, minus the integral of V du. V is x, du is 1 over x dx. So I have a number multiplied by its reciprocal. The remaining work, I just have to find an antiderivative for the constant function 1 with respect to x, and obviously that would be x. One antiderivative is x natural log of x minus x, and you'll remember from Calc 1, we get all the other antiderivatives by adding a constant of integration at the end. As I said before, anytime you can, you should check your answer. So I'm going to take the derivative of my answer and see if it's what it's supposed to be. I have to use the product rule on x times natural log x. I'll have the derivative of x, which is 1, multiplied by natural log, plus x times the derivative of natural log x, which is 1 over x, minus the derivative of x is 1, and the derivative of a constant is 0. So you're going to have natural log of x plus 1 minus 1. The ones cancel out, leaving you with natural log of x. Our antiderivative that we calculated is correct. This is a short introduction into this integration by parts business. In the next discussion, we'll look at some more complicated examples, and we'll talk about a tabular method of doing this, which can be useful in some cases. Until then, I hope everyone has a good weekend, and I'll talk to you later.